Click your screen, probing the senses online. I originally gave this talk in Paris a few days ago for a meeting of the Sensoliers. So I'm looking on the second screen and reading off their name at the CNRS. I tried to record it then, but the recording was really bad quality, hence I'm re-recording it on a Sunday. So let me go to a better screen. Okay, here we go. We're just on the cusp of some very interesting technologies which will allow us to do some pretty amazing things in terms of research. We'll be able to collect thousands of people's data online very rapidly and use some pretty remarkable new sensors which are available in people's home to do some really quite interesting research. In this talk today, I'm going to be discussing some of these technologies and some of the predicted ways in which we'll be able to use the technology in our research. So before we start, by probing the senses, I mean research that focuses on the senses. For example, perceptual psychology. By online, I mean the near instant communication between two individuals. Now, in the past, typically this involved sitting in front of a computer, like I'm doing now. But just recently, the internet's appearing in our pockets, and we're connected 24/7. And I'll be using this progression of past to present to future as an outline of the talk. And I guess that it'll follow this course. The future events will have on computer, then in pocket, on body, and eventually in body. Quite a scary thought. Now during the talk I'll also be contrasting on-web research with in-lab research. In the first half of the talk at least. So there's two key studies which have really looked at how good online research is in contrast to in-lab research. And what they've done is they've taken a range of well-known studies, well-known findings, and attempted to replicate these findings online. And these authors are Laura Germain and Matthew Crump. There's a whole range of other studies which have tried to replicate studies online, but these two studies in particular are good because they've done quite a number of replications in just one paper or two papers. Let's go to a better screen. We won't go through the actual individual studies here, but needless to say that a whole range of different studies have been successfully replicated online, ranging from memory tests to tests which require rapid responses, so reaction time studies. Actually, what one tends to find is that reaction time studies are quite well replicated online, but it's the issue with online is the presentation of stimuli. So if you want to present stimuli for a very short time period, that's when the problems arise. So in these two papers which I mentioned, Germain and Crump, they managed to replicate all of the experiments they attempted to replicate online, did so successfully, bar Crump's seventh experiment, a mass priming study, did not manage to do so for stimuli which were presented for example, 10 milliseconds or 50 milliseconds. Crump's argument was that you need specialised hardware to present stimuli for such short periods of time, such for controlled, guaranteed short periods of time, and that web technology really cannot cope with this at the moment. But For a whole range of different studies and paradigms, online research works. It's a valid technique. Now, for the next part of the talk, I'm going to be looking at online versus in-lab, and we'll build up a scorecard. So, what online's good at, what online's bad at, and perhaps the most well-known benefit of online research is how rapidly data can be collected. Just an example from our own research. This is a quite a small study. We did an online experiment where participants were asked to match shapes with concepts. And in experiment 1, it took a week to collect our data, and we had 81 participants. Experiment 2, 82 participants, and we collected our data in 4 hours. And the really nice thing was that both experiments demonstrated the same effects. In fact, uncannily so, experiment 2's results really did quite closely match experiment 1's results. Of course, there's experiments where you can collect thousands of data points very rapidly, and this is just a small example. Now, in order to collect lots of data very quickly, you need a way to contact lots of people very quickly, and that's where Mechanical Turk comes in. Now, in the past, Mechanical Turk's been used by businesses to ask. Mechanical Turk is essentially a database where people register the fact that they want to take part in paid short tasks, and businesses typically ask say 1,000 people, what colour do you reckon is best suited for this logo, or can you Google for this concept, or can you translate this concept into a better, can you more easily can you change how well this word is written. Lots of very, very short tasks. The participants are paid small amounts of money to do each task. Now, in the recent years, psychologists have cottoned on to this fact and started using Mechanical Turk to recruit the participants. And yes, it's fantastic. You can advertise your task or your experiments, and within a very short time period, very, very many people, purportedly 100,000 people worldwide, 24 hours a day, 7 days a week, are able to see such tasks and decide whether or not they want to be paid a small amount of money to do the task. Now, typically web-based research is less weird than laboratory-based research. And what do we mean by weird? Western, educated, industrialized, rich and democratic are typically what the average experiment's participants can be classified as, because lots of research goes on in laboratories, in universities, and students who perhaps even study psychology or behavioural sciences are typically volunteer to do this research. They're the easiest people to reach. And this is discussed by this paper by Joseph Henrich. His conclusion is that members of weird societies are amongst the least represented populations one could find for generalising about humans. Now, online participants generally are less weird. For example, the age range in which one can sample from is massively broader online versus in the lab. And here we have an in-laboratory experiments, this line here, and I don't recall how many people, I think 200. And the age range was very, very tight. 22.3 was the average age. 90% of these people were female. Whereas this online study with these bars, you can see there's a huge, much larger, broader range of people who are taking part. And the ratio of male to female is a lot healthier than 90% female. So this more closely represents the age range of the population at large. Of course, if you're recruiting online, you also get a range of countries, people in different countries who want to take part in your study. And with Mechanical Turk, these are typically Americans, and also there's a lot of Indians who take part in the study, but also from other places in the world. Cost effective. Now, in our own research, we have been paying participants usually more than $1 per participant per 15 minutes experiment. And now if you think about it, this opens up a lot of doors. This is not a lot of money, and this will let you collect a lot of data in contrast to the typical laboratory-based experiments where participants are paid considerably more to take part. Now just consider though that there's no travel costs to bring the participant into the lab for online experiments, and there's a number of other issues why it is perhaps more acceptable to pay online participants less money. Although, to be honest, I mean, $1 is quite generous contrasted to some of the other research I've seen online. I've seen people attempt to pay people 10 cents to do a 10-minute experiment, for example. 50 cents for a 10-minute experiment, and what on $1 per participant is actually quite generous in contrast to what some other people are trying to pay their participants. So caveats. Now, monitoring your participant. How do you know that the participants are behaving? Now, there's two ways the lack of monitoring may have an effect on your data. The first is that your participants might not understand the task at hand. And this is most certainly a problem if they don't understand the task. What you can do is, though, you can test to make sure difficult concepts are understood by your participants. So in an online study of ours involving tastes, we wanted to make sure participants could understand the term umami. So we have this pre-test to make sure participants really did understand what umami meant. What they did was, there's a range of words outside the circle, and the participants are asked to drag the word into the circle. And if they were correct, they could proceed to the task. There was also a URL here to link up to a Wikipedia article about what umami meant. This sort of step, though, can really help to guarantee that participants understand your concepts in the experiment. So, scammers are an issue. You'll always find people who are up to make a quick buck, and yes, this is a problem. Number of steps you can do after the actual experiment's done is, for example, see whether people have completed the study in a stupidly short time period and exclude such individuals. Scammers tend to be put off having to put effort into asking engaging questions at the very start of the study. So this is a step which Crump and Germain, I don't recall which, I'm afraid, suggest doing, is to ask engaging questions to put off scammers. Unfortunately, there are very few tools out there to identify people who are very good at conducting research, who are well behaved at conducting research online. And for example, if experimenters score participants, assign points to participants who consistently behave well in experiments, and likewise also participants perhaps can assign scores to well-behaving experimenters who don't waste their time. And actually, we're in the process of creating such a system. We're going to be releasing an app soon called Contribute to Science, which will hopefully do this. As with eBay, you rank you buy an item and you rank the seller according to a number of different attributes. We're going to be introducing this system for online and also offline participant recruitment, so that you can really get an idea about whether or not someone will, for lab-based research, turn up to do the experiment, or for online research, whether or not they take the research seriously. If they do the experiment in a stupidly short time period, we most certainly hope that the experimenters will report such participants as being time wasters, making it less likely for future experimenters to be willing to test them at a future point. Keep your eyes open, we hope to release this shortly. Okay, same apparatus. Okay, in the lab you have a very controlled situation with exactly specified monitor sizes, for example, and stimuli of the same colour. And yes, having exactly the same monitor sizes is an impossibility on the web. But one way of getting past this is to, instead of measuring your stimuli in terms of centimetres, is to measure your stimuli in terms of angular distance, angular width, for example. Here's an interesting test. What you do is you close one eye, my right eye is open, I look at the left, sorry, I look at the R for right eye, I move my head backwards and forwards. At some point the L will disappear because it's been occluded by my blind spot. And so from this you know approximately at what distance the person is from the screen by using the location of the blind spot. So instead of the person moving backwards and forwards to arrive at this position, you can actually, as I suggest, dynamically resizing your stimuli on screen, moving the right and the left dots here, so that you know precisely where, approximately where the person's blind spot is, and you can use this to dynamically change the size of your stimuli so that stimuli all approximately fill the same ocular separation over different monitors. It's a nice little hack. It's actually been used for some online glaucoma tests. I was involved in research good 8 years ago in Bangor, and doing research for exploring how to control for stimuli in terms of sizes. We stumbled across this solution, which is already being used. So another issue is the same sound. How do you guarantee that all participants can hear your stimuli, for example? Well, to guarantee that they can hear the stimuli, you simply have an audio password at the start of the experiment, an audio capture, as it were. Please type in 5621 to proceed with the experiment. In order to, if your experiment involves having quiet sounds and also loud sounds, to guarantee that your person hears the loud sounds, what you can do is you can use psychophysics to vary the quiet sounds until you reach the point where you know approximately the minimum level people can hear the quiet sound at, and if you dynamically adjust the volume of your stimuli, you have a nice yardstick in which you now know the lower limits to have the sounds. The upper limits, tricky to test really. I'm sure you could maybe ask people, is this a comfortable volume to have loud stimuli presented at? Maybe that's a solution. So perhaps online research really is only good for visual and auditory stimuli, because what's happened now is with online research, the emphasis is totally changed from the hardware being in the lab to the hardware being in the home. So you rely on your participants having hardware to present appropriate sensation to their nervous system, or to be able to measure appropriate response of the participants. And so here's something perhaps we'll see in our kitchens 10 years time. This is a Kickstarter project by Party Robotics, where they have a cocktail dispensing robot for $100. $100 is perhaps a lot of money, but I mean, as with computer transistors, with time, the cost of the transistors decreases, and as such cocktail dispensing devices become more and more common, perhaps we'll see the prices drop. And I had an animation here, but the animation won't play on the web, unfortunately. And you see the hardware decrease in price over time. Perhaps the copyrights, the patents expire, which introduces competitors who can make similar products to drive the price down. So, I mean, with advancements of technology, hopefully we'll see, and we already have seen, hardware becoming cheaper and cheaper and cheaper, and ending up as standard pieces of equipment in people's households. Just think about the Xbox, for example. The Xbox is in a lot of people's homes worldwide. The Xbox, you can buy an add-on for the Xbox, which is the Kinect, which can do some fantastic things, track the position of the person's body in space, track hand movements, and track head movements and posture. Now, at the moment, this is an add-on. It costs, I don't know, $100 to buy. With the Xbox One, is it called, which is soon to be released, the Kinect comes packaged with the Xbox. And so all of a sudden we're going to have many people who will have very nice scanning hardware in their households, and it just so happens that the Xbox can be connected to the computer, or indeed we could even do research through the Xbox itself to collect some very interesting data. So as soon as hardware becomes ubiquitous, it then becomes valid and easy to do online research very rapidly. Because all we need to do is you need to write one piece of software which can link to that hardware and then be able to collect data from many individuals at once. So what do we do in the meantime until we wait for this eventual Moore's law drop in prices in order for hardware to be cheap for at-home testing? Well, one possibility is to use expectations instead of real sensation. Now, you might think this is far-fetched, but actually it's been used quite a lot in research at the moment. But first, what do I mean by expectations? Here's a strawberry. Let me hide my face. Here's a strawberry. I'm sure you can all taste this in your mind's eye. Really have a look. Look how succulent it is. I'm sure there's one or two people out there who had a puckering of their mouth when the strawberry went a little bit green. And I mean, this just demonstrates how it is pretty easy to have the taste of the strawberry in your mind's eye. You have you have a imagination, a sensory percept of the strawberry, which is produced without the strawberry actually being there. Is it a sensory anagram? I don't recall. But such percepts have been extensively used. This is just one example. Ansel v. Crisnell and Charles Spence in Oxford, 2009. They were interested in pairing up sounds to taste concepts, basic taste concepts. And what they did was they had taste words, sour text in SOUR, salty, SALTY, and asked people what sort of sounds they thought were linked with these basic taste words. So happened that lower pitched sounds associated with, for example, bitter, whereas higher pitched sounds linked up to sour and sweet. Now, Crisnell and Spence actually confirmed these associations with real tastes a year later, which is quite nice, really. It demonstrates that these words produced the same effect as actual tastings. Now, just to demonstrate how probable this is, that taste words can be used in replace of actual tastes. In my own research a few years ago, we did an fMRI study. We put people in brain scanners. We fed people orange juice into the brain scanner with lots of tubing and lots of pumps, and we measured brain activation. But our manipulation was that sometimes we would tell people that they would be receiving a sweet orange juice, and sometimes they would be receiving a less sweet orange juice. Likewise, we gave people orange juice that was diluted or stronger or pure orange juice. So we had weaker tasting orange juice and stronger tasting actual orange juice piped into people's mouths. In these slices of the brain in front of you, the blue blob represents area of the brain that activated more so when people were told they were going to taste a sweet drink and then they received the drink, in contrast to when people were told that they were going to receive a less sweet drink. So actually, this area of the brain is the anterior insula. And let me just sum it up. I like to use lots of hand movements when I'm explaining the brain. The anterior insula the insula itself is a fantastic area of the brain. If you've ever had a brain in your hands, you can actually fold open this area of the brain and peer down into this huge big crevice, as it were. And the anterior insula lies at the very base of this crevice. Some would argue that the insula is a primitive area of the brain in contrast to the rest of the cortex. It has, for example, less layers than the rest of the cortex. The insula is involved in a huge variety of different tasks, but of interest is that the anterior insula and other areas of the insula have been reported as the primary taste area of the brain. Activity here is activity which fires earliest when you're given a taste stimulus. It really is one of the lowest level areas of the brain that activate a taste as soon as you taste something. And to see a modulation of activity in this area of the brain, of course there's the mirror insula on the other side, really suggests that taste expectations can change actual brain activation at one of the lowest levels of the brain. And of course, if you influence activation at low levels, this filters up throughout higher representations of that stimulus, filters throughout the rest of the brain. Really gives a nice example that what Crisnell and Spence were demonstrating, that taste words were just as good as real taste, that this is actually an effect. Let me hide my picture again. Just to mention that others are interested in this such research. Now, it so happens that if you stroke someone between 1 to 10 centimeters per second, that this activates a pleasant sensation. And people such as Professor Francis McGlone and Professor Susanna Walker in Liverpool have been exploring pleasant touch. Now, you would typically use a bulky machine to produce the stimulus. You need to produce a very exact stimulus over each participant in order to collect reliable data. And thus, the problem with this is very slow data collection. You need to bring someone in, hook them up to the machine, do the test. We've just done a web study where we wanted to see if videos of people being stroked would produce the same sort of effect, whether such strokings at a slow rate would be perceived as more pleasant than strokings at different rates. To see if we can do online research en masse, perhaps in addition to this robotic slow stroking research. Of course, we found indeed that slow stroking, seeing people slow stroked in videos, is seen as more pleasant. Of course, what McGlone and Walker will be doing next is they just got a grant to explore this issue, and they'll be putting people in brain scanners to see if there's the reciprocal change in brain activation, which would be what would be necessary to demonstrate this is a true effect. Interesting. Let's fingers crossed for that. Let's hide my picture again. So online versus lab-based. This is the state of affairs now. What happens next? So the question is not whether, we're now in pocket by the way, the question is not whether smartphones will revolutionise psychology, but how, when and where the revolution will happen. Now, a benefit of the smartphone is that you can collect data from many more different sensors, and you can actually stimulate the person through a number of other channels not available to the computer. You have vibration in this, which can stimulate people. In terms of measurement, you have ambient light detection, you have touchscreen, proximity sensors, barometers, vibration, which offers many more ways of conducting research. Actually, I was really quite excited before the Samsung Galaxy 4S came out because it was purported to have eye tracking. But what actually turned out to be the case was that instead of measuring the position of people's eyes, what the Samsung only does is rely on facial recognition and tilt in order to move text on the screen to, for example, scroll text in a box. But that is still pretty cool. So this device can measure, can use facial recognition to do something, and that is most certainly could be useful for research. If you want to have big stimuli presented in someone's living room, here's another piece of technology which may or may not come out in the future. You can have a smartphone with a built-in projector. Touchscreens are another potentially interesting way to collect data. These are not out yet, but they're certainly been hotly researched. This one method, by applying an electric field over an area on the screen, transparent screen, it raises a bump, and of course with a huge number of matrix of such bumps, maybe you can portray tactile sensation. Actually, in the news very recently, Disney announced that they developed a touchscreen which they can apply texture to via vibrations. Now I think they do this by having a current through the screen, and they vary the alternation of the alternating current through the screen. I'm not too sure. It's very well worth to check out this story though. It seems it seems to have a great deal of potential, and fingers crossed it will be on the marketplace soon. So little research, unfortunately, has been done so far using mobile phones. Now, just one example. They used here 5,000 people. I think they used more than 5,000 people. But what they did was, Killingsworth, in a TED talk, demonstrated how they vibrated or they contacted people randomly throughout the day and asked them how they were feeling. What are you thinking about? What are you doing? Very curiously, Killingsworth found that there was a positive association between one's mind wandering and unhappiness. Now, do go and see the TED's talk on this. It's rather curious finding. But, I mean, the massive drawback about doing research on the mobile at the moment is that if you want to write an experiment, you have to write in the native language of the hardware. I mean, for the Apple, it is Objective-C, is that right? And for the Android, it is Java. I mean, this is pretty low-level stuff. I mean, there are researchers like myself, actually, not to brag, out there who do programming such who can program such experiments. We would typically hire someone to make the experiment for us. But this is a lot of effort just to conduct one experiment, really. So every single experiment you do, you have to go away and start from scratch. I'll talk a little bit more about that later. But needless to say, there's a similar set of pros and cons to computer-based research as for smartphone research. I mean, maybe some of these issues aren't so pertinent. No monitoring is offset perhaps by being able to monitor the background noise in the room where the participants doing the experiments, or by using the gyroscopes and movement sensors in the mobile phone to make sure that the person is behaving themselves. My webcam seems to be going dark. Oh well. Same apparatus wise, because Apple's done so well, one possibility is to restrict your research just to the latest iPad. So that's most certainly a possibility. But if you think about it though, iPads, Androids, etc. have a lot of technology in them to conserve power, and maybe in one environment there'll be it's important that they can reduce the brightness on the screen to conserve power. Now, does this have an impact if your research is really keen on maintaining the same level of colour over different participants? I would say that would have an effect. I mean, also there's many different, in terms of vision and sound, there's many more stimulators and sensors available to the smartphone. We fell foul ourselves of it being hard to control for colour over different devices. And in our study, we gave people these, they look like felt tip pens, but instead of colour, they have odour. You take off the lid and you sniff it. And we asked participants to sniff an odour, for example a rice odour, a vegetable odour, meat odour, and tell us on on Android and Apple devices, what colour do these odours do you think associate with? Now, because in some countries we used an Apple device and others we used an Android device, the same Android device over all participants, perhaps there was an issue of colour. So in this control study, using the same population, sampling from the same population, we did indeed find that Apple devices, this vegetable odorant, was reported, people assigned different colours to that odorant in contrast to when participants were doing this study on the Android device. But actually, these are quantitative differences rather than qualitative differences. Subtle shades of greens were the differences. They weren't different colours, full stop. And if this is not such an issue for your research, then maybe you do not need to consider this as an issue. Now, believe it or not, the smartphones are easy to extend, and this is because they have a range of lovely technologies in them which allow you to link up with other devices, Wi-Fi, near-field communication, and Bluetooth, all let you link up to some interesting new technologies which are emerging. Now, one such technology is the Arduino. I have an Arduino here. It's getting very dark all of a sudden. I'm just going to switch on the light. Sorry, one second. One such technology is the Arduino. Here's an Arduino. It fits in the palm of my hand. You can buy a device which allows it to connect to Wi-Fi. Essentially what the Arduino is a little computer which can talk to Wi-Fi enabled devices if you so want it. And the beauty is though that it's really easy to add sensors to the Arduino and thus in an indirect fashion add sensors to your mobile phone. So what you can do is you can either solder up your own sensors and add them to the Arduino, or you can, like me, take a shortcut and buy existing shields which plug straight. So if you see it, they have ports here and little wires here, and you can actually easily I'm saying easily, it should be easier than this. Here we go. You can easily connect this shield to the Arduino with very little effort, and take your sensor, in this case a proximity sensor, plug it straight into the Arduino. Here we go. Here we go, proximity sensor, so it knows how close a nearby surface is. We can now augment your phone with these additional sensors, plug and play. Not quite that easy because you have to deal with the software side of things as well. But still, I mean, this is a simple piece of hardware, readily interfaces with your phone. Fantastic opportunity here, really. I mean, just to say, here's a set of sensors, which what you do is you snap them off. They're the size of a SIM card, each of them, but they're all attached together. They arrive through the post like this, and as I just demonstrated, they have sockets on each, and it boils down to taking a wire, plug it into this end, and plug it into this end, and you have additional sensors. This one has a tilt switch, for example. It knows the angle at which it's orientated. Has a temperature sensor. Has a range of buttons, so you can add different ways for your participants to respond to the experiment. Maybe you want to add a way to measure, for example, the weight of something. I myself have hacked up a scale, and what you do is you can feed information from the scale into the Arduino, and you put your scale underneath someone's plate of food whilst they're eating, get live updates as to the plate of food during the meal. You can even perhaps use the camera itself to see what food people are eating at time X, Y and Z, and get an idea of how much they've eaten. Actually, there are a range of medical devices that directly slot into the Arduino. For example, body temperature, galvanic skin response, airflow, blood pressure. Huge range of different sensors, and this is just one platform. We also have the Raspberry Pi and a range of other different platforms which are similar but offer a range of different possibilities. The Raspberry Pi is a lot more powerful than the Arduino. This is not just restricted to geeks and nerds like myself. Big book companies, for example O'Reilly, are taking this seriously by publishing books on how to interface with iPhone and iPad. Likewise, there's a range of books for the for the Android. Now, can you envision this? You have identified 1,000 people you want to do some research with. You build your devices in lab. You get your technicians to build you devices. The Arduino costs $20. You can get them for cheaper than that. You can get other pieces of hardware even cheaper. Here's your Arduino. You just snap them up, snap them in place, snap on your sensors, post them to the participant, and all of a sudden you can do some very interesting things. So at a later date, you could simply just post your participant another sensor to clip onto your Arduino to do something that was not in the scope of the original experiments. These are reconfigurable, they're cheap, reusable. Actually, there's 3D printing of circuitry. It's just been in the news recently. So can you imagine this? 20 years time, instead of having to post people these devices, you can just send them a PDF perhaps of the circuitry to print and have a working sensor right there in their room within a matter of minutes. So let's go a bit more into the future. Things will start to get a little bit unusual, wacky, and perhaps some of my ideas will be off the mark, but nevertheless, let's continue. We're going to talk about on-body now. We're here at the moment and we're just taking a step into the future. Now you could argue that with smartphones, in this case the Samsung Galaxy smartphone I think it's called, and I know that Google are about to release a smartphone. With these smartphones you can be alerted when you have a text message, so they have vibration I guess. They can take videos, you can even make phone calls from them. Now with these devices, you could already argue that we already are on body, we already have some interesting technologies to do some research with. I think it's still quite early days yet though, and maybe in a few years time we're going to see some more practical ways of conducting research. Now I must say, notice this ring here. I recall a Kickstarter project, a chap in England who's just released a ring that can store your passwords via NFC, near field communication, so that you can have a locked laptop. The laptop only opens up your sensitive information when your ring comes near it. How practical is that for research? I don't know, but maybe you could equip people with rings, have them walk around, say, a museum, and have an approximate idea where they are in the museum and do research in that fashion via near-field communication, activating sensors as they walk. Now, there's also a range of books out there which are discussing how to make wearable technology. Let me share my screen again. Now recall how I talked about the Arduino and how that is pretty cool. Now if you think that's cool, check out this guy. It's called a Seedduino. Oh, I think my image is back to front unfortunately, but it's called a Seedduino. And this is designed specifically to be woven into your garments. Pretty cool. This can do exactly what the Arduino can do, and what you do is you get a range of sensors. I think this sensor here is a proximity sensor actually, and these different sensors can act just like the Arduino can, and wirelessly, if you so want it, communicate with devices in your environment. So this technology exists already. It's just tiny. This is the size of my ring finger. Tiny little device here. Just imagine what you could do with that. Pretty cool. So I get quite excited about my technology. Let's go one more step into the future. So EEG at home sounds far-fetched, but actually a Kickstarter project recently has received 10 times the funding they asked for, over $1 million instead of just $100,000, to develop this emotive insight 5-6 channel headsets, 5-channel electroencephalogram device, and the manufacturers envisage people using this device to, for example, biofeedback, trying to help people to reach trying to help people, for example, reach their empty thoughts. What's that called now? Body scanning, where you go through a series of meditation. You meditate to calm your thoughts, and by biofeedback, you can accelerate the rate at which you can learn how to do this. Now, this is pretty interesting. Maybe within a few years, this won't cost $200 to buy, but will cost $100. Maybe this will be packaged into the Xbox in 10 years' time. It'll become quite ubiquitous technology, and that's the key for online research. As soon as something's ubiquitous, you write your software once, and you can test hundreds and hundreds of people. Another step into the future, but this technology exists. Here we have temporary stick-on stretchable tattoos, which can passively monitor the user and also link up to wireless networks. And on this sensor here, they've labelled EEG sensors, ECG sensors, temperature sensors, strain gauges. This really just is pretty interesting technology. Far less obtrusive than this headset we just saw. So not only is the technology less obtrusive, it gets less and less in your way in the future. I mean, this is fantastic. This will have less impact on your research because there'll be less confounds with participants looking around but feeling something on their head whilst you're doing their research. But the range of actual sensors available really does start to explode, and the miniaturization of these sensors. One more step into the future, in-body. I would love to have this done. This is DIY biohacking. They're called grinders or body modifiers. And in this one example, let me show my face again. The DIY biohacker has implanted a magnet in their finger. And why would they do that? Well, the massive cool factor of that is that when you move your fingernail near a magnetic field, for example, near your computer or near a microwave, or even moving your hand over the wall and there's some wires in the wall, the magnet in your skin will vibrate, because alternating current will lead to movement in the magnet on your finger, and you'll perceive this. You'll sense a touch in the fingertip. Apparently the index finger is the fovea of the haptic system. It's the most sensitive area, and you can consider that on your other fingers that there's also a high degree of sensitivity. This vibration will be picked up. Now let me hide my picture again, because Hamid et al. Went one step further, and they started to artificially vibrate the magnet implanted in people's fingers to attach different sensors, to plug in additional sensors straight into the person's sensory system, to really augment, to hijack the sense of touch. And what these guys were looking at was ultrasonic range assisted navigation. So if you recall, I showed you a remote sensor. I can't find it right now, not to worry. Here we go. They've hacked this straight into the person's sensory system by jumping on top of the tactile system, and we're getting. And in other words, you have a sensor here. You have an approximate idea where things are ahead of you. But this perhaps could be good for blind people, perhaps. Maybe it'd be interesting for people who want to augment their senses with infrared. I don't know. But this is just one channel. We have one magnet vibrating in the finger. You can't really communicate a lot of information at once like that. You can do Morse code, as demonstrated here, but in the finger, in the hand alone, there's probably hundreds upon thousands of sensory channels of information which portray the most basic of stimuli. And one channel, really, we need to go one step further and introduce more channels to convey interesting information, more realistic information. So here, someone has lost an arm, unfortunately lost an arm, but DARPA have been using stimulators which they implant in the remaining tissue to provide direct sensory feedback of the robotic hand to the participant's brain. Here we have a 5-channel device. I'd imagine DARPA used many more stimulators than just 5. But even if they use 20, consider having 20 such wires throughout your body just to provide 20 channels of information. We need multiples of this. Multiple powers of this. And simply enough, with present day technology, our bodies could not cope with thousands upon thousands of such large sensors and such large wiring required. One way of getting past this is to shrink the technology, indeed, but another way, on top of shrinking the technology, would be to go straight to the brain itself. BrainGate, in the media recently, reported having developed a 96 array of electrodes that they implant straight into people's brains. Tiny little array of electrodes, and very curiously, they've reported connecting up robotic arms, for example, and with time people have been able to control those robotic arms. Now, a really lovely example, they've implanted the electrodes in this lady who cannot control any of her limbs, and I don't know if it's this lady, but one of the participants who had the implants, ever since her accident, which led to her lack of movement, has not been able to pick up anything. The BrainGate group reported that this woman actually managed to pick up a glass of drink and take a sip of it for the very first time since her accident. Pretty fantastic. Okay, so we've gone from 1 channel, the magnet in the skin, to 5 channels, the implants in the remaining tissue providing direct stimuli feedback. Actually, do we need many more such interfaces between brain and technology in order to generate anything realistic? I would actually argue that we need some fraction of a fraction of a fraction of the number of interfaces, of the number of, in this case, axonal projections achieved by the corpus callosum. Corpus callosum is the structure, interface, and connecting both halves of the brain together. This is actually my own brain. I have one. It's nice to know. And apparently there's over 200 contralateral axonal projections between the 2 hemispheres. If we do need just a fraction of a fraction of a fraction to achieve anything realistic, we need at least 2 million connections. And if you think about it, not only do we need connections in the motor cortex, we need connections throughout the entire brain, in the sensory areas, in the motor areas, in each of the primary sensory areas, the occipital cortex, the tactile cortex, etc., etc. We need a huge number of connections in order to achieve anything. Oh, is this actually possible? Can we envisage a time when this may occur? Actually, this is a conference paper, if I recall, by CO et al. 2030 in July. The proposal is to have neural dust flood through the brain and randomly lodge at different locations. And for these particles, microscopic, 10 to 100, I don't know the measurement scale, nanoscale, MU, thousands of these such devices lodged throughout the brain, communicating with each other, and obviously communicating with the outside world. And perhaps this is one possibility of building a good link up between the brain and what may be possible online in the future. Maybe 50 years, maybe 100 years, maybe never. So quickly zip through what we covered. Internet-based testing works. Internet participants are less weird. We can do a lot of research very quickly for a good price. The cons are no monitoring and the difference of hardware between your participants. Unfortunately now, only a few sensors can be reached. We might be able to use expectations to get past this issue. With time in the future, we'll find that technology becomes cheaper and cheaper and cheaper. More and more sensors will be able to be accessed by us scientists, allowing us to do some pretty cool things in terms of research. Just some final words. I think the major hurdle at the moment is that us scientists are quite daunted about the possibility of actually coding up experiments for the web, for mobile devices, because we have to use some pretty sophisticated languages to do so. We have to be bombarded with 8 terms of HTML databases, with Objective-C, with Java, and we're just not familiar with this. We're used to in-laboratory software like GMDX. Now, GMDX, Jonathan Forster in Arizona, have recently released an online package in order to do research through, which means you don't have to worry about all this new web technology to your research. Check this out, Google it. My own software, which we're working on, likewise, you build one script of your experiment for lab-based research, and you transfer the script to the phone, to the web. Means you don't have to worry about all these additional technologies. I think this is a step in the right direction, and within a year or two, it won't be so daunting. It won't be daunting at all for us researchers to do research on the web. It'll be part of our tool belt. I think right now, for those brave enough, a combined approach is really valuable, where we take the best of both worlds. We conduct lots of research online and follow this up with maybe in-depth research in the lab. So consider if you have research and you have thousands of hypotheses you need testing, why not test many of these at a very coarse level online, rule out the hypotheses which perhaps aren't so realistic, and then do in-depth research in the lab. So in a combined fashion, we've much eliminated the degree of work required to arrive at some interesting findings. Actually, in Bristol University, we're doing some such thing. We're developing emotional face sets of different people from different parts of the world, and these you might not be able to see, but this lady here has a range of emotions displayed on her face. Now, in order to standardize these emotions across the different peoples from different parts of the world, we're collecting thousands of people's data from across the world online. Once we've arrived at the approximate standardization for the emotions, we're going to go in lab to hopefully verify that we've zoned in on a standardized set of emotions over different nationalities. This is by Marcus Manafo and Ian Pentalk-Voke, professors at Bristol University. So, will online ever replace in lab? I don't know. I think the both will always always working together will be the way forward. I think there's some things you cannot do online that you can do in web, for example. In industry, you have panels of people who collectively arrive at solutions to problems. I work for the food industry, for example, and you present a panel of 12 people, say, with a range of products, and they work together to arrive at. They work together to assess that product. Now, doing that in an online situation, I don't see that happening. In fact, I worked for the food industry in the past. Can you see food being sent to people through the post? Well, most certainly yes. But could you see hot food being sent through the post? Maybe with 3D printing, this won't be such an issue. I heard there's a 3D printer that can print chocolate, but really, who knows? Let's see where the future takes us. Oh, that's the end of my talk. I must say, I come up with whilst fiddling with my beard during this talk, I've thought of another way to augment your senses. It so happens that follicles are very sensitive. Cats, for example, use their whiskers to navigate through the environment. Beardware, why not have a vibrating beard to communicate some channels of information to the participant whilst they're walking around? Maybe not the participant, maybe this could be useful for a hacker to, for example, position a vibrating device that can tell you the orientation of the participant relevant to the magnetic poles of the Earth. Anyway, sorry for the distraction. Thank you for your time. I hope my ramblings have been of use to some people out there. Do get in contact if you want to talk more, and nice to chat. Cheers. Bye bye.